This is the schematic of the main controller. Please bear in mind that I haven't really worked on this circuitry for a year or two, and there's some improvements that needs to be made to the circuitry. So it's not 100% circuit design. Nevertheless, it may be a good starting point. Let's go over the blocks of this schematic. Right here, what you see is the voltage regulators that I use for the circuit. As you can see, I have two different voltage regulators. One of them is a 5 volt and the other one is a 3 volts. And the reason for that is that I need a 5 volt supply for the LCD as well as the USB controller. And other chips on the circuit, such as the GM as well as the XP, they operate on the 3 volt as well as the microcontroller. So it is a little bit inconvenient to have different voltage regulators, because then I have to convert my 3 volts to 5 volts to be able to communicate with the LCD display. But anyhow, that's also been done. On this side, I have the GM862 GSM module, quad band. Nothing fancy here, some simple connections. To XP module, again, very simple connection. So I'm pretty much using their UART of my microcontroller to communicate with the XP module as well as with the GSM module. Now here I have a transistor array network here, and the reason that I'm using it is because for some reason the XP modules really both sinks and sources this line. So I couldn't share this receiving port with my XP and with my GM. It would cause problems. So I had to buffer out the XP output line using this transistor array so that I can connect two devices to this UART port. Besides that, everything else pretty self-explanatory. Some decoupling capacitors, and what you see here is the translator that I have. That I translate 3 volt to 5 volts, the various signals, such as SPI. I convert the SPI 5 volt to 3 volts, and so forth. Right here is the LCD circuitry. I'm using a digital potentiometer to control the contrast. Also, I'm using the shift register so that I can use the SPI to communicate with this display. And this is the switch for turning on and off the backlight. Right here you see the FTDI chip, and that's just simply for communicating through USB with my PC. Alright, let's go over the board layout and explain you the reason I have placed some of the parts where they are. First of all, I chose a relatively large enclosure because these two wireless modules, the XP and the GM862 module, they all specify that in order for their certification to be valid, their antennas should not be co-located with any other antennas, and they should at least be 20 to 22 centimeters apart. That's the FCC regulation. Well, of course, in this board I still couldn't meet the 22 centimeters because 22 centimeters is relatively large, and it's not an easy thing to do. But nevertheless, I tried to keep them as far apart as I could. And this cutout area that I have here was intended for so that I can be able to put a battery. It's an ultra-life battery. It fits an ultra-life battery right here, and connected to the circuitry, because this main controller actually operates with both the battery and also the power supply. The battery is mainly for a backup purposes. Another thing that you may notice on this PCB is that most of my components, all the surface mounts, almost all of them, are on the top surface. One reason I did this was because eventually, when I was planning to manufacture and assemble these and outsource the assembly, the cost is lower if you have all your components on only one surface. However, as you can see right here, these two decoupling capacitors for the GM module had to be put on the back, because based on the guidelines of the GM862, they had to be as close as possible to the pin for decoupling. Now everything else is on this side. On all the switch and the USB connector and the reset are located on top. This actually goes on the edge of the enclosure so that I can have easy access to them. The connector for the LCD is located right here, and I have the GM862 module reset and on and off switch also here, but I wasn't planning to bring them out because I actually do the same thing through the microcontroller. Oh, well, of course, this is the microcontroller located here as well, and this is the connectors for the keypad, and that's pretty much it. Now, if I were to redo this again, first of all, I would make these corners a little bit round. Also, I don't need this cutout. Now, my manufacturer actually charges extra for geometries that have more than 6 sides. So I would get rid of this side as well. Also, there really is no need to have such a large circuitry, a larger PCB. As I said, I still don't meet the 22 centimeters. So my next, if I were to design this again, I would definitely make a smaller board and probably have a geometry like this and avoid the rest area. But at least the nice thing about it is that the board is not crowded. It doesn't look crowded. So it was pretty simple to route this board.